Chapter 12.6 is a continuation, really, of 12.5, in which we're going to learn some special products for very specific rules. What we have listed here are 3 rules. They have some special names. It's not too important. The first one, we have a plus b, that quantity squared, equals a squared plus 2ab plus b squared. Let's go ahead and figure out why this one is the way it is. So we'll start off with a plus b, that quantity squared. Now, when we have something squared, let's say 2 squared, what that really means is we have 2 times 2, repeated multiplication, and then you do 2 times 2 gets you 4. It doesn't mean we distribute the 2 to each term here, if that's squared. We can't do that. We have to first write out what it really means, which is a plus b times a plus b. Now, after we've written that out, we now have a binomial times a binomial, in which we're going to FOIL. So we take the first term times the first term. A times a. Well, they're the same base, so we add the exponents. Their exponents are 1. 1 plus 1 is 2, so we have a squared. And then we'll continue on. Let's do outers. We have a times b. The bases are different, so all we have is a times b, and we can't do anything about it. Then we have our inners, which we have b times a, in which we can't do anything about it. It's just b times a. And then last but not least, we have our b times b, which bases are the same, so we add the exponents, and we have b squared. Now, you might be looking at this and going, alright, that's it, can't do anything more. But I'm going to tell you, these inside terms here can actually combine. And if you remember our commutative law, in which we said a times b is the same as b times a, that means we could multiply where we switch the order. And you can easily see I just used lowercase letters, but if we made them capital, these two things are exactly the same. So I could write ba instead of ba as ab. And if I have one ab plus another ab, I have a total of 2 abs. And this is the formula we saw in the beginning. Let's go ahead and look at the next one. So, this one's done. Check. Now we have a minus b, that quantity squared, in which it looks very similar to our first one, except the only difference is instead of plus 2ab, we have minus 2ab. So let's take a look at him. So, we have a minus b, that quantity squared. We'll first start off where we write out what that really means. We have something squared, so it's that something times itself twice. So we have a minus b times a minus b. And we're going to FOIL. First times the first. A times a, they're the same base, so we add the exponents. So we have a squared. Outers, a times negative b is negative ab. Inners, and let's be crafty here, we have negative b times a, or you could view it as negative a times b. They mean the same thing. And finally, last, we have negative b times negative b. A negative times a negative is a positive. We have the same base, so we add the exponents. Now, looking at those middle terms, the inside terms here, we have negative ab minus ab. So it's like we borrowed $1, and then we borrowed another $1. So for a total of $2 borrowed. And there is our formula. Alright, so that takes care of him. And that's exactly what he was. Last but not least, this one's one of my favorites. It even has a special way to say it. We say the sum, the product of a sum and a difference, so there's a product because they're being multiplied together, is a difference of 2 squares. And now, kind of fancy way to do it. Let's go ahead and look at it. So we have a product going on here. We're multiplying 2 things. One of them is a sum, and the other is a difference. And it's really just a binomial times a binomial. So we'll do first times the first. A times a is a squared. We'll do our outers. We have a times negative b, which is negative ab. We'll do our inners, which is positive b, times positive a, which is positive ab, right? BA, AB, same thing. And then finally our last, b times negative b. Well, a positive times a negative is a negative. B times b, same base, add the exponents. Now, when you look at the inside terms, you see a negative and a positive. So I borrowed $1 and then I paid back $1. Off they go. They cancel each other out and we're left with a difference of 2 squares. A squared, a squared, the b squared, and there's a subtraction going on between them. So there's our third and final formula. And that's it for this section.